Welcome to this Pixotope tutorial. In this video, we'll run through how to get started in Pixotope Director. We'll create and set up a new show, add a camera, and take a brief look at a virtual studio scene and an AR scene. First, you'll need to choose the role for your machine. You can choose between client, server, and standalone. I'll set my machine's role to standalone since I'll be working on only one machine. The Pixotope Director is designed with a virtual production workflow in mind. It's built around the main steps of production, reflected in its different views. The Start view is where you manage your show's and machine settings. The Setup view is dedicated to the initial technical configuration. Here you can set up your camera tracking system, video routing, and color matching. The Production view is meant for the day-to-day operations. Here you can launch levels and control panels, make adjustments to your levels such as compositing and color grading, and manipulate any object in your level. Now that we have an overview of the user interface, let's head back to the Start view. Here you can see the Shows panel. The Shows panel lists all your local shows. It's important to note that projects cannot be opened directly. They need to be linked to a show. Start by clicking Create New Show. Here you have the option to create a new show with a template project. Choose a template that suits your production, either AR, VS, or XR. You can create a show using a pre-existing project by selecting Existing Project. The projects in sync storage will appear in this drop-down menu. Alternatively, you can add a project from anywhere on your system by selecting Other and browsing to the desired project. With my new show open, let's move on to the Setup view. The Launch panel is available in both Setup and Production view. Here you'll only see the levels and control panels of your selected open show. In the Show Settings panel, you have the options to edit your project path, import the configuration and calibration settings from another show, and adjust your base and default settings. The default source settings will automatically populate any new video input or output with the source type, format, and color profile selected here. These can always be adjusted later through the routing panel. Underneath that, we have a couple of engine startup arguments, as well as the option of adding new custom arguments as needed. Now that we've configured our show settings, we can go ahead and add a camera system. We define a camera system as a video input tethered to a tracking data configuration. Select the Camera Tracking panel and click on Add Camera System and give it a name. It is possible to add additional cameras, but please note that only one camera system can be in use per engine at a given time. Under Camera and Lens, you can specify the film back or sensor size using the drop-down menu under Camera Type. The field is also searchable, so you can type directly in here with the name of your make or model. All supplied camera definitions are either 16:9 or 17:9. Their aspect ratios is defined by their film back width and height dimensions. It's important to note that if you do not match the aspect ratios, the output image may be letterboxed or pillarboxed into the output video frame. You can also create your own non-standard aspect ratio by selecting Add Camera Type. Enter your camera type name, and then the width and height of the film back in millimeters. Make sure to check the documentation of your camera for the film back size related to the aspect ratio that you'll be shooting in. Next, select the camera tracking protocol. For this example, I'm working with a system that is using the 3D-D1 camera tracking protocol. Under Advanced, you have additional parameters for defining the incoming tracking data, for example the assignment of axes and the distance and rotation units. Under Camera Mount, you can select the type of mount setup where not all axes are tracked, for example a PTZ head on a tripod. Here you can apply offsets for height as well as offsets to the camera sensor from the PTZ pivot point. Under Lens Tracking, you have the option to enable a lens file and choose between a few of the ones offered in the drop-down. A lens file maps the lens characteristics such as field of view and distortions across the zoom and focus range. While there are templates available, these will never give a perfect result because every lens has unique characteristics, even when they are the same make and model. You should ideally generate a lens file for every lens you use. It's also here under Lens Tracking where you input the zoom and focus encoder limits. Moving on to the routing panel, this is where you'll define your video inputs and outputs. To add the camera we just created, move your cursor towards the top right. When hovering over Camera System, you'll see a drop-down of the camera systems created in the tracking panel. Let's select the one we just created. This camera section has been pre-populated with the default video input format and color profile that we defined in our show settings. You can override these settings as needed by using the individual drop-down menus. Under Channel, you define the input signal type. Fill is the default setting, and it allows you to use the Pixotope internal chroma keyer. Key External Key is selected when sending a separate fill and key signal to your system. You'll need to set up a separate media input for the key signal. Fill Key External Key is selected when the signal is keyed externally and provided as a combined fill and key signal. In the tracking section, you define the connection settings for your camera tracking system. It's important to note that while the Pixotope tracking service monitors all listed IP addresses, we recommend always setting up your tracking system on a separate dedicated static network to avoid any potential packet loss or delays. The status will update to display the incoming tracking data frequency once successfully connected. Along with the camera system, you can also add additional media inputs if you want to include other untracked video sources in your level. Select Media and then Input. Give the input a name and then select the appropriate source. Let's add an output as well by returning to Media and this time selecting Output. Give the output a name and assign the appropriate output destination. Please note that it's critical for your production that the video input and output frame rates are the same. Finally, in the routing section, we'll configure the genlock and timecode signals. At the top of the routing panel, you'll find a section called Lock. Here you can select the reference type you are using. Choose External Ref if you're using an independent genlock signal, or select the appropriate SDI spigot if you're locking to your SDI input signal. To add timecode, we once again go up to the top right part of the routing panel and click Timecode. This will then add a timecode section below our genlock where you can select the incoming timecode signal. Timecode is not mandatory for a single machine production, but it is a requirement for multi-machine environments. Now to the calibration section. The tracking panel is where you can fine-tune the incoming camera and lens data by applying offsets. Below the tracking panel, we have the delays panel. Here you can adjust the delays for each signal in order to match up the tracking data and video input perfectly. You also have the option to apply lens delay independent of the camera tracking, which is useful when using a combination of optical and encoder-based tracking. With the show configured, let's move on to the production view. I'll launch my virtual studio level in editor mode. Once the level opens up, I'll go to the video keyer and select Enable Video Keyer. To start off, we want to sample some of the colours from the background we would like to separate from the talent. We can do so by clicking the Initialize Key button. This will grab a single frame from the incoming video, which we'll then be able to sample colours from. Let's start by selecting some of the flat green colours in our video. In addition to the background samples, we also have the option to sample colours from the foreground, which helps us maintain the foreground elements. This is useful if you're working with any problematic colours that are close to the selected background colours, such as cyan or yellow. As you can see, the key already looks good, but we can always refine our key further if needed. To better see adjustments made to the key, I can enable the Send Key to Video Output. Now, I will adjust the background fader. And then adjust the Add Luma Key Fader as well, which helps to fill in transparent areas of the foreground and add more details in the softer areas of the key. Now I'll deselect Send Key to Video Output to see the final result. And as you can see, our talent seamlessly transitioned into our virtual studio environment. Looking at our camera input, you can see our talent is being projected onto a 2D compositing plane in front of our virtual camera. It's important to match the distance between the virtual camera and the compositing plane with the distance between the real-world camera and the talent. We can check this by going to the top left of our viewport and changing the view to top. Now I can hold the mouse wheel to measure the distance between the virtual camera and the compositing plane. I can then compare that figure to the distance between the real-world camera and the talent in my studio. Now let's go ahead and launch the AR scene. With the scene loaded, let's go through the Pixotope world settings to make sure we have everything set up. We're going to make sure that Enable WYSIWYG is selected, and in addition, under AR settings, ensure that AR WYSIWYG is also selected. Also ensure that the compositing type is set to AR. And now that we have our AR scene set up, let's press play. That's not an ideal placement for our logo. Let's look at moving that into a better position. Back in Director, let's go to the Object page in the Production view. I'll open up the Objects tab on the right hand side and browse to the logo. Now let's push it back a bit in the X-axis. And also move it close to the ground by lowering the Z value. Great, now that's looking much better. For more information on this or any other Pixotope subject, be sure to check out the Pixotope Help Center, link in the description.